many questions like that. So our main focus will be on maybe the method of integration. And since we can't do everything here, so we can talk about how then do we integrate what is important to notice. So before we differentiate, though, we may want to know that if you're given y is equal to sin x, then the dy dx is equal to cos x. The dy dx is equal to cos x. And then if you're given y is equal to cos x, then the y prime, which is the dy dx, is equal to minus sin x. This is significant so that when you integrate, you get the reverse. You get so to be asked to integrate is to be asked to give what was differentiated for you to have that thing integrating now. So I think the actual integration starts from question 8, so back to going to question 18. So let's pick a question from question 8. So we have integrate, we'll pick this one. Now let's pick A. Integrate 10x to the power 9 minus 12x to the power 3 minus 5 dx, like that. So to integrate, you use what we call extended power rule. If you're dealing with such kind of powers, you add the 1 to the power and divide by the same number. You add the 1 to the power and divide by the same number. And then sitting here as 5, it's like 5x to the power 0. So you add the 1 to 0 and divide by the same. And then you add a c. We're adding a c because we know, should there be any constant, when we differentiate, we get 0. So we still have back the function of the integrator. So this gives us, there will be 10 over 10 will be cancelled. So we just get x to the power 10 minus 4 into 12. That's 3 x to the power 4 minus 5x to the power 1 over 1 plus the constant. Like that. Okay. So that is the basic integration. If we go to E, E is saying, are you able to integrate 6 over x to the power 5? I can see properly there. Minus 1 over 7 x power 3. Okay, I want to combine this question with this one. 9 to the cube root of x to the power 7. Maybe let's also combine and say plus 3 over the square root of x dx. So we just make it a bit interesting. This was supposed to be E, but we have extended it a bit. Just to make it a bit nice. Okay, so if you're asked to integrate such a thing, you would write it to the powers that you can easily add one. It's just rewriting, you're not doing much, you're just rewriting the same things. So you say, okay, this will be the integral because I haven't found it. Of what? Of 6 x to the power negative 5. Because it was in the denominator, when I pushed the numerator, it becomes a negative 5. Minus 1 over 7 x to the power negative 3. Look, you don't move the 7 to the numerator. You leave 7, it's just a constant. We're interested in the variable because that's what we integrate, not the constant. Minus 9 x to the power 7 over 3. That cube root, it goes as the denominator for 7, which is at the half. Plus 3 x to the power minus half. Dx like that. And then now we start adding 1 now to the power that we have. So we have 6 x minus 5 plus 1. And then we divide by what we will get. Okay. Minus 1 over 7 x minus 3 plus 1. Then we divide by what we get. Minus 9x 7 over 3 plus 1. Then we divide by what we get. Okay. Plus 3x minus 1 over 2 plus 1. And then we divide by what we get. Add a C. So you expect this simple integration. It shouldn't be that hard in our mind. So this is one method that we have. And it's called the extended power rule. So we move. We pick a question from question 9. And then we go to 10. Just like that. So 9. Let's pick A first. There's an integral of 6 sin x minus 2 cos x dx. Okay, so to integrate sine, since the derivative of cos is negative sine, to integrate sine, we will multiply it by the negative for it to become cos. Because we know when we differentiate cos, it will give us a negative. So that negative times this negative, then we'll go back to positive sine. And then for the cos, it remains the way it is because it's derivative. I mean, the derivative of sine is a direct cos. So we'll just put a sine here. And then add a C. Okay. And now bring in E, the integral of tan, open bracket, cot x minus cos x dx. Okay, so this one is, you can expand it. So say tan x times cot x minus tan x times cos x dx. Like that. And then from there, we understand that this can be written just for us all to see. Cot is like 1/10. Tan is sine over cos. Then we are multiplying it by cos. And then this is dx. So we have this guy over that. And we get 1 minus this guy over that. Then we get sine. And then we have a dx. Then we integrate. The integral of 1 is x. And the integral of minus sine is cos x. And then plus c. Sometimes it may look a bit complicated, but then you just react it a bit. Try to split it, and then you get to enjoy what you have.
So after integrating this sine x to cos x, aren't we like maintaining the sign, the negative behind the sign?
No, because you're saying we're looking for a function whose derivative is negative sign. So a function whose derivative is negative sign is cos.
Okay.
We got to question 10. Now we want to have the integral of x squared now plus 2 multiplied by e to the power x dx. Now, one thing we should enjoy is the integral of e. Because the integral of e, first for x squared, it will be x3 now over 3 because we're adding a 1 to the power. And then plus 2, the integral of e power x is e power x. Okay? And then plus c. So the integral of e power x doesn't change. So here, if we integrate 1, you get x. If you integrate sine, you get negative cos. Now negative cos times this negative. When you have a plus. That's why you put a plus here and not a minus. It's knowing what the integral of sine is. The integral of sine is negative cos. And since there's another negative here, the two negatives will multiply. Okay? Maybe another nice one would be D or 10, where we want to integrate e to the power minus x. And then we have e to the power 2x plus EX dx. So you first expand. So you multiply E minus X times E to X plus E minus X and E X dx like that. That is E, since we have the same base E, we go to the powers and add them. We haven't yet integrated, we are just adding the powers. Then we come down and say, okay, this is like E X plus 1. Plus 1 because E power 0 is 1. So we go to plus 1. Then from there, we integrate EX, we get the same EX. We integrate 1, we get X. Then we add this. So you see that? Quite easy. Well, I also want to show you a question of this kind. I haven't seen it here. Today, ask you to integrate maybe e to the power 4x. Plus x power 3, for example. Yes. So to integrate the e to the power 4x, what you do is you differentiate 4x. The derivative of 4x is 4. And then here we have the x y over 4. Plus c. So to differentiate an exponential, means to integrate an exponential.
Please repeat.
Okay. So to integrate an exponential, you differentiate its power and divide the exponent. So we have to differentiate 4x to get 4 and put it here in the denominator. Then you do the addition on the right. Okay. So let's move a bit. Let's go to question 11. Question 11. We'll start with D. So D, we have the integral of x minus 2. And then E at the power x squared minus 4x. And then dx. Yes, therefore is the derivative of 4x. Okay, so when you're asked to integrate a product, don't be so quick to start integrating. look at the function. Okay. This product is made in such a way that the things we see there are related. So because it's involving exponentials, we'll get the power of the exponent. So let u be equal to the power of e. And then differentiate it. So we get to x minus 4. So we get to x minus 4. Like that. Then if we cross multiply, as we factor out the 2, we will have x minus 2 dx. And then we solve for dx. So we make dx a subject by dividing this. So these will cancel here. So we remain with dx being equal to du over 2 x minus 2. For now, we go back and do the substitution. So we leave x minus 2 here. And e, its power has been called u. And the dx is now du over 2 x minus 2. So that this part and this part can cancel. And so when that happens, we'll now have 1 over 2. So this 2 can be taken out in the denominator because it's in the denominator already. And then we'll have e to the power u now, du. Now remember that the integral of e is just e plus a c. So we go back and remember what our u is. So our u is x squared minus 4x. And then put back the c. So this is the integral.
Sir, kindly repeat from the left-hand side where you started cancelling the x minus 2.
The x minus 2. So the x minus, so look, because you have a product, and you look at how our product is, we go to the power of e and let it be our unit. Then differentiate that power. So we get 2x minus 4. Now we are already seeing the x minus 2 there. We want to see if we can get it out of this thing that we have. So we decide to factor out a 2. And so it looks like 2x minus 2. If we cross multiply the dx, so the dx will cancel. Then since our integral has a dx and not a du, we want to solve the dx in terms of du. That's why we're dividing this so that the dx remains alone. Our job then will be to substitute in the integral. So x minus 2 e to the power u du over 2x minus 2. Then this and that cancels because they're the same, and one is the numerator, one is the denominator. So they would cancel out. Then the 2 is just a constant that is sitting in the denominator. So you could plug a 1 from up there and take it out. And then we integrate e to the power u du. We get u plus c, the constant. And so we have this as our integral.
Sir, what method is this?
Substitution method. So you focus much on because the products, we have an issue with integrating products because don't have the product through here.
All right, thank you, sir.
So we move now to the next thing. Which is now the integral. So I'll skip the by parts part. I'll go straight to the definite integral. If you're asked to integrate from 0 to 1, I'll just pick something that is not complicated to demonstrate the method. So let's say x squared plus 3 dx. So your job is you integrate this guy, you get x power 3 over 3 plus 3 multiplied by x, and then you have this. This means substitute 1 throughout wherever there is x, and then substitute 0 throughout wherever there is x. So you see, we're going to get 10 over 3 minus 0. That's how you treat the definite. So this is called the definite integral. So when there are limits involved, you want to differentiate, you want to integrate and then substitute the limits, starting with the upper throughout where there's x, and then ending with the lower throughout where there's x. Okay. So your much interest is so your main focus is you really need to just have an idea of it. So that should they bring something that's not that complicated and you're able to solve it? Because you have the idea. So you solve it. Yeah. The other thing we should appreciate is the integral of 1 over x is equal to linear plus a constant. So this will mean now every time I will have a derivative in the numerator and the function whose derivative is up in the denominator, then the integral is going to be ln of u plus c. Okay. The integral is going to be ln of u plus c. Every time we are going to have the derivative up, and this is the mostly used when you're asked to integrate via a partial fraction. Remember, we did it demonstrate the other time when we had the simple fraction and partial. So when this time, we'll try one question on partial. Of course, this session could only accommodate this part. So we may have to, when we do the combined selection of different concepts, Then we also pick on one which is under partial, and also one which is on finding the area. There are only 2 questions remaining for this duration. And so we're not going to jump and mix up concepts. We will do as agreed in the group. So this is what could be accommodated under the integration class. The methods are very important. So you don't have to stress much to know integration. Let's go as far as what we can know. And then now when we come back, we're going to go into this binomial, that binomial. We talk about the important things there. If we get some space, maybe we can add 1 or 2 from the interval. In another class, we have 3. Agree. So don't go far. The next thing we come back and talk about binomial. We keep cheating.